Welcome everybody, this is video number 28. We're still in unit 4. This is about protons, neutrons, and electrons.
Rub your fingers on them and bang on them. Bill. Now this material turns out to be aluminum, and this material turns out to be copper. Now the main difference between this material and this material is
the number of protons in the nucleus?
the number of protons in the nucleus. You can see and hear the differences. Bill! Hey! Now, scientists have grouped all the different materials, all the different elements that we can find into groups, which have come to be called periods. And we've arranged the periods on a table, the periodic table. So let's go to the chart.
The periodic table.
The table.
Yeah.
The periodic table. Voila! The periodic table. See? Every element has a name, and you know most of them. They're familiar. There's carbon, oxygen, aluminum, copper, iron. They're familiar. But there's some weird ones, too. There's like erbium, palladium, and krypton. Scientists have given each element a 1 or 2 letter symbol and a number. Now, that's not just any number. That's the atomic number.
The number of protons in the nucleus?
The number of protons in each nucleus. Now, there are 92 elements that occur naturally.
So protons equal the number of electrons, and this is definitely a Burkeism that I have down here. In order to be a happy, fun element, you have to be what's called an electrically neutral element. And all elements exist in nature this way. They do not like to be positive or negative. They like to be neutral. So what does that mean? That means that all your protons have to have the same number of electrons to go with it. Otherwise, you would be positive or negative. And we don't want to be, we want to be 0, right, in order to be happy and fun. So if you know the atomic number, which is the number of protons, then guess what? You totally know the number of electrons as well. Please be super very careful and don't tell me the atomic number is the number of electrons. It's not. It's a little bit of a semantic thing, meaning that the atomic number is the number of protons and electrons equal that number. So be very specific about that. Examples for you here that you guys did before. We did oxygen, carbon, hydrogen, iron, and nitrogen. I just want to show you these two numbers match. So if you know one, you know the other. Atomic mass equals the number of protons and neutrons, basically everybody that lives in the nucleus. It is very easy to find because it's always the decimal number, and that's the one that's located usually below the element symbol. Now again, in some weird periodic tables, if you Google them, they might be on the side or off to them, but you can always tell what it is because it's a decimal, and it's an average, and I'll get into that in another video what that is. Another thing it can also be called is atomic weight. So if you're looking at a periodic table and it says atomic weight, it does mean atomic mass. So go ahead and put me on pause here for a second, and I want you to go back through to our 5 elements we've been working with and find their atomic mass. I hope you did well. I hope you came up with oxygen is 15.999 and carbon is 12.011, hydrogen is 1.0079, iron is 55.847, and nitrogen is 14.007. Now, hold on. Did you write down all the decimal points? If you didn't, they would be wrong, okay? If you just wrote down 15 or rounded it up to 16, you would be wrong. The atomic mass has to have all the decimal places. Now you're like, what's up with the pictures, Mrs. Burke? So this is my time to stop and ask you, am I blowing up your marbles? Meaning, am I confusing you? Or are you happy, fun student down here? Hopefully the latter is true. If not, rewind me and do it again. What I'm going to teach you today is finding the neutron number, and of course I have my favorite Jimmy Neutron below to help you remind you about neutrons. So don't forget, our neutrons are a housemate with the protons in the nucleus, and this is one you actually have to do some math for. So you have to take that atomic mass, that decimal number, and you have to minus the atomic number, and that's how you find the number of neutrons. What I'd like you to do is use our 5 elements again and see if you can find the number of neutrons. Go ahead and put me on pause. Me and Jimmy Neutron, and that's Goddard, by the way. We'll wait for you. Go ahead. Find the number of neutrons for each of your elements here. So for oxygen, we did 16 minus 8. And yes, I know I rounded them this time. If you are looking for the neutron number, you absolutely can round your mass number. But if you're going to report out the mass number for me, you would have to give me the decimal. So here we go. So we did 16 minus 8 is 8 neutrons for oxygen. 12 minus 6 is 6 for carbon. 1 minus 1 is actually hydrogen has no neutrons. Iron is going to be 30 and nitrogen is 7. I hope you guys are doing well. I hope I didn't blow up your marbles too much. Don't worry, we're going to do a ton of practice with this. This will become very easy for you because we'll do a lot of it. Taught you how to find your protons, neutrons, and electrons. I actually gave some of the answers here at the bottom. And we also talked about atomic number, mass, and symbol. You will absolutely be required to know how to do this, but don't worry, I'll give you plenty of practice in class. Good luck. If you have to watch me again, please do that. That's what these are for. Summary when I see you again in class. Thanks.